My name is Justin Wilson, and today I'm presenting on the topic of ICS asset inventory, active or passive, for Siemens S7-1200 PLCs. We'll be going into asset inventory, examining some differences between active and passive, and what you can do to improve your asset inventory. I'll introduce myself real quick. My name is Justin. I started programming PLCs, programmable logic controllers, in 2015, and I really fell in love with industrial control systems during that job. I had previously taught myself several programming languages, and I enjoyed creating websites for friends and family, that sort of thing. And then when I started programming PLCs, to me, it opened a whole new world, because now instead of writing code to create a web page or interact with a database, I was writing code that would interact with the physical world. I could write code that would make a saw blade cut or an arm move and make things happen physically. It was really cool. It was like I was programming these giant industrial robots or something. And so I really fell in love with industrial control systems. I think they're just a lot of fun to work with. So I did that for several years, and then I transitioned into cybersecurity. And shortly after that, I found a home doing ICS cybersecurity. So I'm back in the world of industrial control systems again. And I love being here for many of the same reasons. I think it's a lot more fun and exciting to protect these critical infrastructure systems, these industrial control systems, than it is maybe a database or some corporate assets. It's a fun place to be, and I enjoy being here. So that's a little bit about me. We'll go ahead and jump into the presentation here. So my objectives for this presentation is that by the end, you'll understand if it's possible to create a complete and accurate asset inventory for Siemens S7-1200 PLCs using passive traffic analysis alone. This was my research question behind this. I wanted to find a better way of doing asset inventory. And so my question was if this was possible, if it could be done. And then also, you'll learn specific engineering triggers that could substitute as a low-risk catalyst for collecting asset details passively that you might not see during normal operation, and that you would otherwise rely on active queries, active discovery techniques to find. And whoops, I forgot to mention the most important part. In doing so, you can increase asset data by up to 275%, just by knowing how to stimulate these asset details. So before we jump into the research, I want to talk briefly about asset inventories and why they're so important. So the reason that we create ICS asset inventories and spend so much time on this is because it's hard to protect what you can't see, especially when you're getting down to the device and component level. If you don't know what you have, it's hard to protect it. It's hard to do detailed alerting and detection on your assets if you don't know where they are and what they are. Visibility is often regarded as one of the first steps in building a cybersecurity program, just figuring out what you have. And asset inventory is also an important part of most cybersecurity frameworks and requirements. For example, the NIST CSF lists hardware and software asset inventories as the first due to items of the first technical function within the framework. So now that we've talked about ICS asset inventories and why they're important, let's talk about the four basic ways that there are to build an ICS asset inventory. Traditionally, this is done using one of four ways, often a combination of these four. First one is a physical inspection. And this is where you're physically going to sites, to cabinets, to different locations, and you're looking to see what's there. You're writing it down, maybe you're putting it in a spreadsheet. And this is a good way of determining ground truth, but obviously it's also very labor intensive, and it's not self-updating. If something changes, you're not going to know about it until the next walk down, which may be a year or more later. Configuration analysis is the second way of building an ICS asset inventory. This involves looking at the engineering files, the PLC project files, maybe examining network configurations or firewall rules to figure out what's in the system and what is talking to what. And again, it tends to be a manual process. There are ways to help automate this, but it's not exactly self-updating in most cases. So it won't always be the most up-to-date way to build an asset inventory. Then there's passive network analysis. This is where you're looking at traffic from a tap feed or a span or a mirror port, and you're using software to analyze the traffic and automatically build this asset inventory for you. So the benefit here, obviously, is that it's automated. It can be updated very quickly. New changes are quickly detected. The downside is that if you don't have everything tapped, which most organizations don't, you're not going to see everything. And so there can still be gaps in your inventory. And then the fourth way is what we call active discovery or active queries. And this is where you're actually talking to these devices. Now, today this is done using industrial protocols. So you're talking to a PLC in the language it understands to query it for information and get those asset details back. This can be very robust because even if something isn't tapped, you can still go out and talk to it and query it for details and get the information that way. However, introducing non-standard traffic into an industrial process can be risky. So that's the downside there, and we'll talk about that more in a couple of slides. So for the purpose of this paper, I'm going to be talking about these last two, active and passive analysis. So the debate between these two is active versus passive. Which one is better? And this is a question that you'll most likely come across as a cybersecurity engineer. And there are definitely pros and cons to both. Passive is considered very safe. You may need to install a tap or configure a span or mirror port during a maintenance window. But after that, this method is invisible to the industrial process. It doesn't know that it's there. You're not introducing new traffic, so it's considered very safe. You're just listening. Now, compared to active discovery methods, this is where you're talking to a PLC and saying, what are you? What is your rank, name, and model number? And you're getting active information from it that way. This can produce more asset details, and you can find more assets this way. But again, that can be more risky. So let's talk about that. When it comes to building an automated asset inventory, this is easier to do in the IT world than it is for OT or ICS. In the IT world, you have many rich sources of information, such as Active Directory, open source scanning tools like Nmap. You have commercial scanning tools that go out and inventory your network for you, and you can rely on security agents, which will collect telemetry about your endpoints. But in the world of OT, these data sources are either unavailable, too IT-centric, they just don't understand industrial components and protocols, or they're too risky. There have been some documented examples where things have gone wrong when IT traffic was introduced to an OT network. For example, there was a case where a 9-foot robotic arm swung 180 degrees while in standby mode while someone else was in the room. Thankfully, they were not injured, but that could have ended differently. In another case, a ping sweep caused some delays in a production facility and caused $50,000 in wasted product, in damaged product. And in another case, some pen testing activity locked up a natural gas SCADA system for 4 hours, causing natural gas to be undeliverable during the length of the outage. So while none of these activities like ping or some basic light pen testing activity isn't inherently bad or dangerous in an IT network, it is in an OT network. Now, there are OT safe scanning tools that exist, and these will talk to devices using their native languages. Instead of using a ping, for example, it'll use Modbus or S7 or Ethernet IP and talk to a device using the language that it understands. And this is much safer and a much better way to get information from industrial components. However, there has been research showing that even these OT-centric scanning tools can have an impact on the performance of PLCs. Specifically, it can slow down the scan time, or in other words, the amount of time that it takes to execute instructions. They can slow that down in some cases by up to double. And that could be bad news for a high-speed network, for a high-speed process. So my question is, what if it wasn't necessary to scan ICS at all? What if there were things that you could do as an ICS cybersecurity engineer or as an OT engineer to help enrich asset inventory through passive analysis without actually going in and talking to these devices. So my hypothesis was that engineering workstations, EWS, would produce greater asset details, maybe, than a PLC would on its own, just during normal operations, maybe talking to an HMI, for example, a human machine interface. Under normal operations, a PLC will talk to an HMI multiple times per second to keep the information on the HMI up to date. But what if, if you're downloading code or uploading code from a PLC, maybe that would contain more asset details that you could then collect passively. So these engineering workstations, they have vendor-provided programming software specific for these industrial components. The software is used to download code updates or upload code from a PLC, make changes while it's running, stuff like that. And so my hypothesis was that this traffic would contain more asset details than regular background cyclical traffic. So the experiment. For this experiment, I captured network traffic of 11 different scenarios. I'll list a few of those here. For example, I captured traffic of just 1 minute of background cyclical traffic between the PLC and HMI. And then same thing with 1 hour and 1 day, thinking maybe, well, maybe there's some kind of a handshake or a broadcast that only happens once every few minutes or once every few hours. So maybe monitoring for a longer length of time would produce additional asset details. And then I captured traffic of downloading a program change to the PLC using the engineering software. And then for another experiment, another one of these packet captures, I just interacted with the PLC using the HMI. So I would push the buttons, turn variables on and off, change the set point to see if interacting with the PLC through the HMI, as would be done in an industrial process anyway, could produce additional asset details. For this research, I also used some commercial OT purpose-built scanning tools to scan the PLC and also to analyze the traffic passively to see what I could find using those commercial tools. And yep, I went and saw which details could be extracted from each activity, each test that I did, each packet capture. So I used the script to do a first pass on the results on the packet captures. And this is what it looks like. Don't get bogged down too much by the details, but focus more on the ratio of red to green. Red means that an asset detail, a piece of information was not found. Green means that there was a potential match for that specific asset detail. So compare this screenshot of 1 minute of cyclical background traffic to this screenshot of a go online operation with a PLC. There's a lot more green here, which was a good sign. It meant that potentially you could get a lot more asset details by doing something as simple as connecting to a PLC. So after running the script, I went and validated the findings using Wireshark to make sure that data was there, see what other additional information I could find in surrounding details. So this is an example of what it looks like. Highlighted in red there, you can see the PLC order number, which is kind of like a model number, and the firmware version or partial firmware version. I left off the last digit in this case. But we can see that that information is clearly there. It's fairly nicely parsed out. I did have to use a custom protocol parser for Wireshark to get this much information because I couldn't get this much without that. But we can definitely see that that kind of information is there. So after doing these experiments, doing some active queries against the PLC and taking these packet captures of different activities, I went and scored each of these activities, each of these tests, to see what asset details could be extracted from each test. And I just want to summarize the findings and go over at a high level what I found. So the bluish column here, this is the active query commercial tools. Now, interestingly, with the 3 commercial tools that I tested, active queries failed to some extent for all 3. For one tool, tool A, it failed completely, just wouldn't even work with this protocol, with this device type. I talked to the manufacturer. It was a bug in the code in that version. I just got unlucky. And then for tools B and C, the active query functionality succeeded, but with some errors. And so it didn't extract as much information as it perhaps could. Now, interestingly, with the commercial tools, I was able to extract only up to half of the in-scope asset details that I was looking for. I did test some open source active scanning tools as well that were specific to Siemens PLCs. I used Nmap with the S7 script, a publicly available script called siemensScan.py, and also the Python Snap7 library to query I use these to query the PLC, again, to see what kind of details I could get from it. And at most only 4 or 5 pieces of information. I was not able to get a lot through the open source scanning tools. Now looking at the right half of the chart, this is the manual passive analysis section. So this is where I was doing those experiments, capturing network traffic of different events, different types of interactions to see what asset details could be produced. Now, those first 3 columns, those are the no interaction columns where I just let it sit for 1 minute, 1 hour, 1 day. And all 4 of those contain the same level of detail. So the finding there is that recording for longer with no additional interaction is likely not going to produce additional asset details. And then so for some of the other experiments, I did things like pressing the buttons on the HMI, setting a new set point. I tried exiting the runtime on the HMI, like the program that's running. I just exited out of it, went back into it. That produced a few more asset details. I tried cycling power to the HMI. That produced the same results as just exiting the runtime, so there was no really additional benefit there. And then I tried going online or connecting to the PLC and downloading codes, downloading new code, performing a download with no new code, uploading existing code, etc. And what I found is that simply going online with the PLC, just connecting to it and not doing anything beyond that point, produced a great deal of asset information to be transmitted and captured. And this is significant because what it means is that a low-risk activity like connecting to a PLC can produce a lot of asset information. You don't have to do a download or an upload or make some kind of potentially disruptive change. All you'd have to do is connect and disconnect, and you can get quite a bit of information that way. So the verdict, looking at all passive methods combined, I was able to identify a total of 15 out of the 18 in-scope asset details, or about 83%. And this is specific to the engineering traffic. Compare that to only 4 matches in the cyclical traffic between the PLC and the HMI. It's quite a difference. We only saw those 4, only 22% of asset details were available in that cyclical background traffic, which means that we got a 275% increase in the availability of asset details by introducing some engineering activities. So going back to the question I asked at the beginning, is it possible to create a complete and accurate asset inventory of a Siemens S7-1200 PLC using passive traffic analysis alone? And the answer, unfortunately, is no, not quite, but you can get much closer by analyzing engineering traffic, by making sure that that engineering traffic is included in your analysis. So what are the implications of this finding? Well, it means that asset owners can produce a more complete asset inventory by performing routine engineering tasks. Likely at some point throughout the quarter, month, year, your engineers are going to need to connect to the PLCs, do updates, maybe do a backup. And so if you can make sure that this traffic is captured, you're going to get a lot more asset details than you would by just capturing the cyclical traffic, which may be all that exists during normal operations. And therefore, these engineering tasks can be at least a partial substitute, if not a full substitute, for active scanning capabilities for commercial tools. I feel like this is especially important for sites that do not support 24/7 packet capture. A remote site, maybe out in the desert, that's connected, that's networked via a 2G modem, probably isn't going to be able to stream traffic back home for monitoring and analysis. But if you're going out there to take a packet capture for the purpose of building an asset inventory, you want to make sure that some engineering tasks are included in that capture. Connect to the PLC at a minimum if you can, because that's going to produce much richer asset details, and you'll have a much better asset inventory by including that engineering traffic. Now, there's a caveat to all of this, and that is that not all asset details were nicely parsed, especially by both commercial and open source tools. And I'll show you what I mean by that. So here's another screenshot from Wireshark. This is looking at some asset details that were seen for the digital output card. So I had the PLC and then a digital output card attached to it that would be used to control the industrial process. And we can see here a possible match for the firmware version, a match for the order number, and a match for the serial number. Now, unfortunately, this was not parsed out nicely at all. If you look in the bottom left corner of the screenshot, about halfway down that pane, you'll see it says item value blob. Basically, what this means is that Wireshark picked up the data. It knows that this blob data exists. It knows where it starts. It knows where it ends, but it doesn't know what to make of what's inside of it. It's not able to parse details out into this is the order number, this is the firmware version number, etc. So these asset details are visible in network traffic. You can find them if you're looking for them and if you know where to look, but it's not nicely parsed out, meaning you couldn't just put a filter in Wireshark saying, show me all of the order numbers or all of the serial numbers, because it wouldn't find them because it's in this unparsed traffic. So an additional bonus finding that came out of this is that active queries, having seen that they failed to some extent for all three of the tools I tested, this means active queries are not a silver bullet. I feel like a lot of vendors talk about them like they are, like, oh, you have to use active queries to get everything, and that's how you'll get the most details from your ICS assets. And I don't want to talk down the idea of active queries. I think there's definitely a place for it, and it is very useful. I personally have seen great success with it in industry and in production environments. It's just a limitation to be aware of. So in summary, yes, engineering tasks can enrich passive analysis results. If you can capture those activities, you're going to have a better asset inventory. Then also, active queries aren't a silver bullet. Don't rely on those alone and assume you're getting all of the asset information. You should at least do some validation if you're going to be using active queries. And ICS asset inventory, it's a complicated topic. There's a lot to consider. Protocol versions can change from one device family to another, or even within the same device family from one firmware version to another. And if the vendor doesn't support all of these configurations, you may not be able to detect everything passively or actively. So ultimately, asset owners have to do their own due diligence, test the available tools, and compare it against the known inventory and see which tool will work best for their environment. So with that, are there any questions?
Justin, thank you very much. This was very informative. I learned so much about the world of ICS through this. I was wondering if you can speak a little bit more about the practical aspects of triggering or conducting engineering activities while monitoring the network. You had mentioned a possibility of going into a remote site, doing some network capture while also interacting with the device. Is that often a single person who can do both, or do you need to have two types of individuals involved in this activity? Perhaps along these lines, would you expect that security practitioners who are monitoring the environment and hope to catch these kinds of engineering activities will need to coordinate? Just kind of was wondering if you can comment not on the technical aspects of the approach that seems to work quite well, but on the just real world friction introduced through collaboration and coordination with other humans.
Sure. So I think it's going to vary a lot from one organization to another. Sometimes people take on multiple roles, and the OT engineers are also the security engineers just because they don't have anyone else who understands OT or security. So maybe the most savvy person on the most security savvy OT person on the team will be the security guy by default. And so in some cases, maybe they will be able to do that, but in many other cases, probably not. It would be good security practice to have a separation of duties where the security guys do the security things, the engineering guys do the engineering things. And so in that example where maybe you're going out to a remote site to do a packet capture, you might want to bring one of those OT engineers with you so that he, as the authorized person, can connect using his authorized laptop to that system to perform activities that only he is authorized to do. So there can be some hoops to jump through there, but it's, you know, if you have a good relationship with your OT engineering guys, then that's something that you can collaborate on and work on together for sure.
Thank you very much. Yeah, I don't have any more questions.